We generally have an operations update from Michael Brandt, and he is here to do just that for us this evening to report on the most recent major activities at the lab that would be of interest. We're tracking a number of projects up there on the laboratory site. And so, Michael, take it away.
Great. Thank you, Daniel. So Katie will be advancing my slides. Katie, can you go to the first slide? And I'll be giving a brief update about some things that are of interest. I'm going to go back in time a bit because there are so many new people, but we received a nearly $3 million grant last spring from CAL FIRE. And this was the third time that we had applied for that grant and we were awarded the grant. So we've entered into a partnership with campus on vegetation management projects, and we're focusing on wildfire reduction. And in November, so there are certain requirements that we need to go through, and you'll see a timeline along the bottom of this slide. And this past fall, we received approval from the California Environmental Quality Act review that was done by the state of California, which means that we are now able to move to the next step, which is to publish an RFP and evaluate the bids that come in and award a contract. And we are looking forward to beginning the fire mitigation activities both around laboratories property as well as along Centennial Road and along the boundary with campus. And that's our commitment to the community, where we're going to do everything we possibly can to reduce wildfire risk. And this is one of the things that we can do. So we're very pleased with the state of California, CAL FIRE in particular, for awarding us this grant to do something good for our community. Next slide. And at our laboratory, we've been undergoing a modernization campaign certainly since the early 2000s. The building in front of you is the most recent building that has been under construction since late 22, and this is called our BioEpic building. And BioEpic is this building is a combination of our environmental science programs as well as our programs that are at the cellular level. So if you think about this building, we're going to examine from the cellular level to the ecosystem level. And one of the unique features of this facility will be we will have simulated environments in ecopods, which are basically environmental chambers inside the facility, which will be connected by telemetry to locations around the world in alpine environments as well as in tropical environments, and we'll duplicate those environments inside these ecopods, and we'll be able to manipulate that environment within the ecopods to look at the different impacts on plants. And so this is plants at the cellular level as well as at the ecosystem level. So this building, we're very excited that the building has been undergoing construction for quite some time now. And we're focusing currently on mechanical, electrical, and plumbing installations and so on. So we're finishing up the interior. We have a modular utility plant. What we do is here at the laboratory is that we have a modular utility plant which serves a number of buildings, and we've expanded the modular utility plant that we refer to as the MUP. And we're now going to be connecting to the BioEpic and energize that facility so we can take that building to the next step of electrifying the building and running the utilities. And so the completion of this building is scheduled for a year from now. We're looking forward to completing that project safely and with high quality and begin the move-in process. Next slide. So we also have another construction update for you, and this is a live picture. Katie, it looks like you took this at 4 o'clock today, and this is our seismic safety and modernization project. Our previous facility was a cafeteria that had some meeting rooms in it. The building was more than 70 years old. It was an outdated building, but most importantly, it was seismically unsafe. And you can see that we're constructing on a 45-degree slope. So this is quite a complex construction project. In the background, you can see that we're installing retaining walls, and we'll be doing the same thing coming along the front of the curve of this building. We're referring to this as a welcome center and cafeteria. It's going to serve as the central hub of the laboratory, where we'll be upgrading the transportation and utilities coming into this area. And this will create the foundation for a new central commons for the lab. And we hope to be able to open this building sometime in 26, but I'm not going to commit to an exact date at this point, because this is one of the most complex construction projects that we've encountered. And right now the project is moving along according to scope, schedule, and budget. So we're quite pleased with that. And assuming that we stay there, we're hoping that sometime in 26, we'll be able to move in, probably in the fall sometime. Okay, next slide. Another project, and this project is a replacement for the Centennial Bridge. And as Katie is running the images here, what you see is the current Centennial Road on the left-hand side. On the right-hand side is the new expansion of the bridge, and that bridge is built to all current seismic codes, and we're looking forward to completing that bridge and be opening up the road, moving the road over to the right-hand side in sometime late in the summer, and then we'll take down the existing bridge, which is in the laboratory's property, and remove the soil, and then construct a new security gate, which will improve safety and traffic flow in that area. So we're really looking forward to having this bridge finished. The bridge is a state award, $15 million to the laboratory, $15 million to campus. Campus has been managing the project, and we've been collaborating with campus, and we're quite happy with the progression of this construction. I just as a historical note, I have a memo that was dated August 29th of 1963, and the original cost, the cost of the original bridge was $170,000 back in 1963. Wow. And this is now a $30 million bridge, and we're really looking forward to improving this, certainly the seismic safety, reducing landslide risk, and opening up a modern bridge for connection of the local community from campus to the Berkeley Hills. And this serves as a central evacuation route in the event of a regional emergency. So we're really looking forward to having this project completed, and it's been very well managed. Next slide. And so I want, each year the laboratory is graded according to 3 rubrics for our science mission accomplishment and the way that we conduct our science and the quality of our science, 1 for leadership, and then the remainder for our operations organizations from ES&H and facilities management and security and so on. And this is the 3rd year in a row that our laboratory has received an A- or higher in all 8 of the DOE categories for evaluation. And in fact, our security organization received an A grade, which is rarely given. And our laboratory was identified as the top performing laboratory in operational security of all 17 national labs, and we were recognized by the Department of Energy. To achieve these results, which are unprecedented, requires that we function as a leadership team, and all of us, regardless of our role at the laboratory, work together in teamwork to support our science, execute our mission, to solve complex problems in service to the nation. So we're quite proud of this, but we also know that each and every day we need to continue to operate with excellence, focus on improving each and every day, and communicating with one another and conducting our work safely. So I thought I would raise that because it certainly distinguishes our laboratory from the other Office of Science laboratories as well as the other national labs. But we also know that we're only as good as what we've accomplished today. And so I'm quite proud of what we've accomplished as a laboratory team. Thought we would share it with you. And so I believe that's my last slide. Any questions?
Very good. Thank you very much, Michael. Any follow-up points from the group? Questions, comments, observations? Diz, go ahead.
Thank you, Michael. And congratulations on the A- as the lowest grade. That's quite phenomenal. I'm impressed. As we've had tours of the lab post-COVID, we often see vacant desks and so on. And have you modified at all your building designs to accommodate the new normal?
Well, I'm actually glad you brought that up because we had a leadership retreat today, and we average about 60% of on our daily badge-ins compared to before the pandemic. We are committed to being a hybrid work environment, and the most populated days at the laboratory are Tuesday, Wednesday, Thursday. The shoulder days, Mondays and Fridays, perhaps less so. And we have made some adjustments to our the way we use our space. Space is at a premium. You can see that we're investing in modernizing our facilities and constructing new buildings. And so we're doing things such as consolidating our Office of Chief Financial Officer group. And that consists of about 200 people. In that organization, there's more than 50% of those people are fully remote and the remainder are hybrid. So we're doing everything we can to optimize space, such as if you're at the lab a day or fewer, you have access to hoteling space. If you're here 2 days or more, you will continue to have a dedicated office space. And we want to use our space wisely because constructing these buildings are quite expensive. The BioEpic building is about a $170 million building. So space is at a premium, and we're consolidating out of rental space in the area, and we're bringing people back to the lab. So we have incentives for people to be at work, and we've seen that people are returning to the laboratory. And again, we do support hybrid work because that is a competitive advantage for us. And we do find that our postdocs and scientists interact well together by being here, knowing that they're going to be here on three days. That way the teams can come together and work with one another and collaborate. And so that keeps us as a vibrant intellectual community.
Excellent. Great. Thank you, Michael. Any other questions or comments on Michael's presentation and operations update? Okay, I would just comment on the bridge project. You reminded me of a podcast I heard recently from GBH Public Broadcasting in Boston, and they have an excellent review podcast investigative report on the Big Dig, as it's called. You might have heard of it. It was the replacement of the Central Artery Freeway, which is an elevated freeway, and they deemed to put it underground and restore the surface with Rose Kennedy Greenway and all of this stuff. It is a fascinating story. And the project went from a few years to completion. It took over a decade and more. And needless to say, the cost escalated. I mean, Michael, you said the bridge for the Berkeley lab project was under 200,000 and went into the millions. Well, they went from a couple of, I think, 7.7 billion to something about 10 or more times that. I think it became the most expensive public works infrastructure project in the United States. So it's a fascinating story. Check it out. It's a
Well,
brilliant.
Daniel, I will tell you that we manage our projects carefully, and we have oversight from the Department of Energy, and
Right.
we keep contingency. We cannot and will not go over budget.
Right.
That's the worst possible thing you can do. So we tightly scope our work. But I'm very familiar with the big dig. We will have no big digs here.
That is
Knock
correct.
on wood.
Absolutely. It's a marker out there. Check it out. All right. With that, we're going to go to our next presentation, and that's Kelsey Miller, who's a program administrator for the lab's Human Subjects Protection Program. So, Kelsey, the floor is yours.
Well, thank you so much for this opportunity to present to the group today. I'm really excited because my job is primarily to think about the communities that we're working in with our research and to really think hard about what they need from us in order for us to be doing the best research we can do the most ethically way possible. And so this is exactly the kind of forum where we like to get feedback, and we're really excited to be here today. All right, so the Human Subjects Protection Program. We wanted to kind of start just to give you set the scene of research and how research is a never-ending continuum that doesn't start with the sponsors. A lot of people think it starts with those who are funding the research, but we consider it to start with the communities, because you can't fund a research project until you identify a problem that you need to solve. So the DOE and many sponsors work very closely with communities to try to understand what is needed. Where are the gaps? What kind of research do we need to fill those gaps? And for DOE, I've got the 4 pillars here in the center to represent the 4 tenets of energy and environmental justice. The DOE Office of Energy Justice and Equity really focuses on these tenets, and it's a really important part of what we do in the Human Subjects Protection Program, because bringing the justice to those who've been mistreated through the years is really one of the #1 things that we focus on. And so benefits to society and equitable distribution of those benefits, as well as those research burdens of participating in research, is something that we focus on in the Human Subjects Protection Program. So how do the researchers then get to the communities, right? Well, the IRB is the first acronym that you're going to learn today. So we are called the Institutional Review Board, and we are a part of the regulations that go into play when you're doing research with human participants, but we're also a big part of ethical best practices. And so we're going to get into a little bit of the history of human subjects in the world and the United States, and then with the lab. So, all right. First off, setting the stage with our acronyms. So we have the 4 big ones here. I have HSR at the top. The HSPP, you've already heard now, the Human Subjects Protection Program. And then we have the IRB and the HSC. So let's dig in. HSR is what we term human subjects research. And those are capital letters in HSR because it is a very specific definition of what meets human subjects research. And therefore has all the regulations come into play. And so it's not just any old research that has to do with people. It is specifically research that uses identifiable private information or interacts directly with the subject or has an intervention that they're putting in place with a person. So it's a very specific definition, but HSR is what we call it. If you're doing HSR, you're coming to me. That's the idea. So the IRB is the Institutional Review Board, and that is the general term in the US regulations for a body that reviews and approves human subjects research. And so the IRB at the lab is called the Human Subjects Committee. So the Human Subjects Committee was established quite a while ago, and we have been working at the lab for decades. You'll see in a timeline that I've got coming up. And then the Human Subjects Protection Program is what we call the entire program that goes along with the IRB. So while the IRB, the Human Subjects Committee itself, is actually doing the review and the final approval of the research, there's a lot of other policies and guidance and determinations of whether or not it is human subjects research that's handled by the protection program. And so our HSPP has lots of other duties that go along with the review of these research studies. All right, so let's get a little bit into the history of human subjects protections. And some of this is really unpleasant, and I don't want to skip over that. I want to, own it for what it is. When the Nazi trials were happening in 1945, there was a lot of atrocities that were revealed, and that began the long process of establishing very solid human subjects regulations. So the Nuremberg Code was established during the Nazi trials, and it really gave 10 points of requirements for humane experimentation. So it was the first time that there was clear documentation of the need for consent, the need to minimize risks, ensure that any experiment has true benefits to society or the individual. And so this really began a process where the world was starting to open its eyes. And so you'll see many other dates here, but some of the most important ones are 1953. So in 1953 is when NIH became better prepared for clinical research that it was funding and started to require the review of that research by a panel for human subject protections. And if you recall, back then, the National Cancer Institute was really starting to ramp up. And so cancer trials were a major part of why the NIH really stepped in first and foremost in the United States. Now, in 1964, there was the Declaration of Helsinki. And so that was adopted by the 18th World Medical Assembly, and they really established the baseline ethics of conducting clinical research. And so that really started a much closer dive into whether or not there should be higher level regulations. And at that point is when in 1966, the Public Health Service, which has NIH in it, but also has other Health and Human Services Department funding, they extended that NIH requirement to all of the research that was supported by their agency. And so that was really the first time that every research body in the United States that got public funds started thinking much more closely about having these panels involved for all clinical research and other research that involves human subjects. So in 1973, there was the public disclosure of the 30-year government-supported Tuskegee syphilis study. And that is one of the biggest hallmarks of the atrocities that were committed against the marginalized communities in this country. So if anyone does not know about that, just in brief, there were many men in the South of the United States who were not offered treatment for their syphilis, even though treatment was available at that time. And they instead chose to misinform those men and study syphilis for their lifetime without providing them treatment. That was something that was considered absolutely unethical. And at that point, the National Research Act was put in place that really made the bridge of all research that is conducted with human subjects, regardless of the funding. If it's federally funded, it cannot be done without a review board. So this was what really established IRBs in the first place. And it also created the National Research Commission for the Protection of Human Subjects and Biomedical and Behavioral Research. So that commission ended up spending 3 years to research what were the best ethical frameworks that should be put in place for this kind of research. And what they came up with was the Belmont Report. So the Belmont Report is a very well-known ethical framework that takes beneficence, respect for persons, and justice as the three primary things that have to be considered in human subjects research. Now, as a part of all of that, the federal regulations were being put in place at the same time. And so in 1981 was the very first version of the federal regulations, which were codified in 45 CFR 46. And those regulations went through a few iterations until in 1991, they were deemed the common rule. And they're called the common rule because the 20 US federal departments and agencies all follow those same regulations. And so they all have their own version of the same federal regulations that are all codified in our federal body of regulations. Now, the DOE and many other agencies also have their own specific protections. And so the DOE order was published originally in 1990, and it's gone through a few versions. We're now at 443.1C, and that's for the protection of human research subjects. And so that has been going in parallel with the common rule for some time. And in 2018, the common rule had some further revisions. And so now we're working on the revised common rule, as it's termed, for the federal regulations. The DOE order has its own additional requirements. And then we always follow the Belmont Report as the basis of what the IRB stands for with ethical principles. So there's a whole lot of history and a whole lot of terms for you to look up later. But let's get more into what the lab has done. So human subjects protections at the lab. At the time, it was called Donner Laboratory, and the Donner Laboratory Committee was established in 1945. Notice the overlap there around the time of the Nuremberg trial and the Nuremberg Code. So when that first happened is when the laboratory decided that they needed to have something in place to review the use of radiation in human participants. So if you look at the picture there at the bottom, John Lawrence himself and Orlando Lawrence, they were working together. They were doing a lot of this kind of medical experimentation. And it was the beginning of what has become now cancer radiation treatments. And so the work that was done at the lab back in the 40s and 50s made a huge difference in the medical treatment of cancer. And there are many studies that continued throughout the 60s and 70s that have really been pioneering this process for medical doctors to use today. So at that time, the committee was only looking at the safety and the appropriateness of the doses and really tracking what was going on at the lab. And then in 1966, which aligns with the Public Health Service's decision to have review requirements for research that it funded, UC Berkeley established its own advisory committee at that point. And so we would have some of our research that was funded through PHS sent also to the UC Berkeley committee. So we had the Donner Laboratory Committee only for the radiation experiments, and then the advisory committee at UC Berkeley was covering the rest of our research with human participants at that point. In 1975 is when the new regulations from the National Research Act came, and those required IRBs to be registered. And so UC Berkeley went ahead and registered their committee, which is called the Committee for Protection of Human Subjects, as an IRB. So at that point, we decided as the lab to go ahead and continue to use our Human Subjects Committee, which it was now called, for pre-review of all of our experiments. But then we would send the final research protocol to the Human Subjects Committee from the UC Berkeley. And so UC Berkeley was operating as our IRB for 35, can I do math today? 43 years. So for quite a while. And UC Berkeley was expanding their research at the time as well as us. And so by 2007, we had a review from the DOE Human Subjects Protection Program. And it was a recommendation that we have our own registered IRB instead of using the UC Berkeley committee. And mostly that was because we all had more and more work to do, and they wanted to ensure that we got a good independent review of the program here at the lab. Because we were expanding our research and the UC Berkeley program was expanding so much, they wanted to make sure that we were getting access to what we needed from the Institutional Review Board. So in 2008, we were officially considered our own IRB, and we've been operating independently since then. And so the Human Subjects Committee is kind of new on the IRB registration list, but it is definitely not new to the lab. We've been reviewing research for a very long time, even before the regulations were put in place. I'll pause real quick. Does anyone have any questions about the history? Because now we're going to go into what we do today and how we function to review research.
Not seeing any questions here.
Great. All righty. So what do we do today? This is the fun part. Human subjects research at the lab looks a lot different than you may expect. I think most people hear human subjects research and they immediately think of biomedical experiments. And while we do have our own bucket of biomedical research, it is not the largest part of what we do. So we do have one group who works in the biosciences area, and they do create their own radio tracers to give people PET scans and look at their brains. So they have some really great research going on for Alzheimer's disease and other cognitive ability. And so it's been a very good program that's been running for quite a while. And it runs in conjunction with UC Berkeley and UCSF. It's a very collaborative program. We also do a lot of research that falls into this bucket just because it's identifiable data. And so if you have identifiable private information about people, then that counts as human subjects research. And so we look at projects that are using health record data. And there's some work that is trying to come up with better evaluations of health records through computing sciences to help doctors determine what they should be looking at and highlight risks that maybe they wouldn't see otherwise because the computer can do such a great job of running those calculations. Another thing that we do at the lab is we collect a lot of information about consumer activities, and that's to inform policy decisions, tracking who's able to get solar, how many people were able to get that solar energy put on their house, and where is the equity lie? How can policy changes help to make it more accessible to those who can't get it right now? So we look at a lot of things like that. Another big section that we do, and I'm going to go just clockwise here around our circle, is surveys and interviews. So surveys can be a little bit of everything, right? Collecting the general public opinion on how people are utilizing new technologies, whether or not they're interested in new technologies, what policy changes could be made to help adopt more clean energy technology. I think all of that is a really important piece of what we do at the lab. We also just have regular studies on opportunities that are provided. We do research on how good our internship programs are, how much we're actually impacting the communities that we live in. And so we do surveys and interviews of a lot of different stakeholders to try to make sure we're doing research with the most informed, up-to-date information that we can find. Lastly, I'm going to talk about the modification of the human environment. So that's a fancy way to say we're going to change something about your business or your home, and then we're going to see how it works. So we go into homes and we replace technologies such as your heater or your water heater. And we do our lot of monitoring to understand how those technologies are working in homes so that we can better understand what it's going to look like when everybody transitions to the newest technologies. We also do a lot of monitoring of indoor air quality And that helps us identify hazards and develop interventions that can help make changes in the built environment around us to help us all live healthier lives. And I believe Hugo is going to talk more about that later. So you'll be able to hear a lot more about indoor air quality and all the work that's happening here at the lab. So we do a lot of different human subjects research. They're all a little different in the projects. And actually over 50% of the projects that we review and approve are done by the energy technologies area. So while the biosciences area is our second amount in 32% of our protocols, ETA actually does the most. And so that energy technologies is a very exciting and growing sector of human subjects research. Our computing sciences is also there, and even our earth and environmental science group has started initiatives to increase the community engagement that they're doing so that they get more feedback from the community. And so we're really excited to see this blossoming across the lab. All right. So what does the Human Subjects Committee do? Well, we do a lot of reviewing protocols. So we look at lots and lots of things. And what ends up happening is that everybody has to come to us at the very beginning before they start doing any of their work. And we look at the entirety of their project and how they're going to interact with people. And we apply 3 basic criteria. We have our common rule criteria for IRB approval of research. So those federal regulations, have they met all of the requirements of those federal regulations? Are we in compliance? We have the Belmont report, and we ask, are these the ethical best practices to protect the people who are being enrolled in these projects? Are they maximizing benefits? Are they minimizing harm? Informed consent is one of the most important things in human subjects research. And that respect for persons element of the Belmont report is very key, where individuals are autonomous agents. They can make decisions for themselves if they're given all the information. And so our job is to make sure that they're given everything they need to know to make an informed choice about participating in research. And then lastly, the DOE regulations are a little more conservative than the federal regulations themselves. So we even look at research that is considered exempt from the common rule because the DOE has higher expectations for the conduct of that research. And we have annual reporting to the DOE so that they can keep track of how we're using taxpayers' money in order to recruit these participants and enroll them. All right, so that review process it can take months, it can take a week, it totally depends on the project, but we review all the research that's happening here at the lab with human participants. And then who are we is a big question that we always get, right? How do we know what's the best thing to do? Well, we have a broad array of membership. We have our scientists who have to inform what we're doing. So we have scientists in computer sciences. We have social scientists who specialize in surveys. We have the bench scientists who know all of the intricacies of the way that these things will interact with the body. And we have medical doctors as well, who are required to review FDA research. So anything that falls under the FDA, because it's a drug or a device, we always have a medical doctor who looks at those to make sure it meets all of the expectations. But that's not all. We also have non-scientists. So as a part of our committee, we are required by the regulations to include non-scientists so that they can look at the research from that lay point of view to really think about it as a person who would be enrolled. And if you don't know about the science, can you still understand that consent form? Do you still know what you're signing up for? So they play a very important role, and we have people in the finances, we have people with bioethics in the backgrounds, and we have musicians too. So a little bit of everybody. And then unaffiliated members are the other really important piece. So these are also required by the regulations, and they're people who are not otherwise affiliated with the lab. So They're here just to inform our research and let us know what the regular community members are thinking. They can be in any profession. And what we usually are looking for is people who represent the participants that we're recruiting for our research. We recruit a lot from the general public, but we also are recruiting people for Alzheimer's research. So people in that community are important. People who are in the Central Valley. We do a lot of research in that area. So we don't only want to have people from Berkeley. We want to have people who represent that area where we're actually doing the research. So it's always a struggle to get as many people as we can to represent the community that we're engaging with. And so that's part of why I'm here today. We wanted to talk to you about maybe helping us out in finding somebody that can represent our community for another person on our committee. So I won't read through all of this today, but I have given Jen a handout for you all to better define what the unaffiliated committee member does. But the key thing to remember is that we would love to have people who are really representative of the communities that we work with and in. And it would be wonderful if you could share this opportunity. Unfortunately, we can't have any of you because you are affiliated with the community advisory group, but maybe other people at your organization or other people who are interested in what the lab does. We are actively recruiting and we're going to take as many people as we can handle so that we can really get the best perspective because we're there to represent the people we're participating. And we can't do that without people from outside of the Berkeley Lab community. So I hope that you will consider this option and share it with your friends and family. And hopefully we'll be able to get some new folks on our representation. It would be really great to have you guys engaged.
Very good. Excellent. Thank you, Kelsey. A whole bit of history there, as well as bringing us up to present day and call for volunteers to join your process there. Excellent. Any questions or comments from the group? We're open to that. We're on schedule, so we welcome your feedback. Comments, questions? Anybody? Suggestions, possibilities for volunteers that you know might be interested?
Well, feel free to share it far and wide. I did notice that some of you are from organizations that do other kinds of energy research. And so it'd be great to have it in that, realm. Diz, did you have something?
Yeah, so what are the areas that, oops, am I muted? No. What are the areas that of expertise or knowledge or whatever, Alzheimer's you mentioned, what are the areas you want most?
Yeah, that's a really good question. So people who represent or work in vulnerable communities, so that would be really great. Somebody who works more with lower income, English as a second language. There's a lot of research that's happening in lower income areas. And so anybody who works with those communities or is a part of those communities, that would be a really great element to add to the committees. I think we're not restricting ourselves, right? So if we get a few options, that would be wonderful. I think, I mentioned Alzheimer's, but any kind of cognitive dysfunction or anyone who's taking care of an elder, those kinds of things are really important too. We would love to get that perspective.
I have a lot of those.
Okay, great. Thank you, Diz. Any other questions or follow-ups there? All right, well, we can give Kelsey a round of applause. Thank you very much for your presentation this evening. Excellent, very
Thank you for
informative.
having me.
We appreciate that. Okay, we'll follow up with the group and hopefully there might be some volunteers coming out. We'll see how that goes. Okay, well, we'll go to our next presenter, which is going to be on the topic of indoor air quality research, and that's Hugo Descalles. So Hugo, would you like to share your screen, and we will move on to the next agenda item here. All right, take it away.
Thanks. So let me unmute first. And great. Well, thank you very much for the invitation. It's a pleasure to be here. I'll try to give you a brief overview of some of the topics we are working on at the Indoor Environment Group. Let me see here. So our group has a very long history at the lab, and the topics we cover are really very broad. So if I had to give you just a one-line definition of what our group does is we're really interested in the nexus between indoor air quality and building energy efficiency, understanding that we are, of course, in the Department of Energy realm, and these two areas are really interconnected. So given this diverse portfolio that we have, I want to tell you what I'm interested on. It's a subset of all of this, and it has to do with pollutant sources, exposures, our interactions with them, how the contamination changes over time, from an environmental chemistry point of view, which is my field of research. And that information eventually can help developing, policy standards, innovative materials, or new technologies. So today I will be talking about one area that I personally have been very interested in working for a long time, which is tobacco smoke, and more recently vaping or emissions from electronic cigarettes. Before we do that, I think it's always interesting to give you like the bigger picture, some historical perspective. And I understand this is a very busy figure, so we're not going to go into all of the details there. Just to look at the overall, main message, which is, in this figure, we are showing on the y-axis the number of cigarettes consumed per person per year in the United States over more than a century, right? And very clearly, we see there is a peak here in the 50s and 60s. At that time, we could say more than 40% of adults were smokers. And we can compare that number with today. Today, that number is 15% in the whole country and about 12% in California. So that means there was great progress done in the last few decades. And I could say our group can claim some of that, in this declining trend over the last many years or decades, related in particular with the understanding of what is secondhand smoke, and especially the fact that we cannot really control it, we have to eliminate it. So the policies related with 100% free, smoke-free environments have a lot to do with the research my predecessors, the senior people that founded our group in the 80s and 90s have done at that time. So now that continues today, and as we make progress, also new questions arise. And in particular, now we have eliminated all of smoking in public places. The major impact of smoking now is in the home. And that means we have to refocus our research in that direction. Also, I want to mention, you see the map here. This is a global problem, obviously, and in the US here we have fairly advanced, but many other regions of the world are still kind of where we were, in the 50s and 60s. So the research we do here also has benefits that go beyond our country. And in particular in California, because we are funded by the state of California, we have a very ambitious goal to reach 2035 without, let's say, active use of tobacco, which is really, it looks like an extrapolation of this curve, but it's difficult to reach. So our research portfolio right now has three elements that go in that direction, or at least try to support that research. One is the impact in the home environment, which I'm going to describe now in the next few slides. The second topic is electronic cigarettes or vaping, and how that new element, which only started about a decade ago, how that affects tobacco use, and also what are the new questions that arise from electronic cigarettes. The third element, which is the role of cannabis, is also more recent. We are only started to work on that, so I'm not going to give you a lot of details on that research, but this is a very exciting new direction that we are taking right now and in the next few years. So let's start by, what's the impact in the home? And we actually have defined this term third-hand smoke some time ago. We need to define it. So we know second-hand smoke, this is the fresh emissions that people are exposed directly and are mostly through inhalation and in a very short time frame of seconds or minutes, following the smoking event. And by contrast, third-hand smoke is related with contamination that even if it comes from smoking, it lingers on surfaces mostly in our environment for a very long time. And these surfaces become reservoirs, emission sources, and also a medium where chemistry happens. So what we try to do is to understand that chemistry, understand those long-term processes and how people are exposed, which is in this case, not just by inhalation, but also through thermal and ingestion mechanisms. So I'll give you a few, snapshots of our research in this field. From the chemical point of view, we focus on nicotine. Nicotine is emitted by cigarettes in a relatively large amount, and it's fairly persistent indoors. So that means homes that are contaminated with third-hand smoke will have a lot of nicotine coating their surfaces. And in one of this study, that was one of our earliest, described how nicotine can react with nitrous acid, which is a common chemical present in indoor air, to form carcinogens that are called tobacco-specific nitrosamines. And this reaction can take place even long time after smoking happens. So that means this is a process that can be a constant source of carcinogens in the environment. We continue doing more work over the years on this particular question, and I'm showing here a more recent study in which we evaluated the dose of those nitrosamines that can be uptaken by non-smokers over time. So what we predicted here is what are the exposures and also the negative health effects that are related with them. The doses were quantified for the main exposure routes, which are inhalation, dust, ingestion, and thermal uptake. And what we found is that given the fluctuations and the very broad ranges that you see on those bars, there are situations in which at relatively high levels, all of these mechanisms can cross this line, which is what the state establishes as a daily dose that would represent a significant risk level, above that level. So in summary, a prolonged exposure to high levels of third-hand smoke, we consider that could contribute to higher cancer risk. So this was a study from 2022. It was featured in the cover of the journal, and I think it somehow supports the overall idea that this indoor chemistry actually has potential health consequences. Another element, or something that we have been working on for quite a while here, is understanding remediation technologies, or what can we do if we live in a home that that we know is contaminated with smoke. And the problem is that there is very little solid scientific evidence that either validates or disproves the efficacy of some remediation methods. We studied one of them, which is the use of ozone. There are these machines that are ozone generators that one can either buy as a consumer, or you can hire a company that would come to your house and release ozone using these machines. So what we did here was a couple of studies in which we used the ozone generator inside one of our environmental chambers. You see the photo here, it looks a little bit like a room. It has vinyl flooring, drywall, regular construction materials. So what we did in this particular study was to release smoke from cigarettes and then allow the smoke to settle and then produce the ozone and see what happens, see if we can quantify the effectiveness. And in the second study, which is more recent, what we did was more or less the same approach, but we also had there a carpet that was retrieved from a smoker's home. And for that reason, it was a material that came already to us with a heavy load of contamination. And then as general observations on both, actually the carpet, I'm showing here the photo because remember carpet has we have two different materials, the backing and the top layer, we analyzed both of them. In general, what we found is that indeed ozone does react with third-hand smoke constituents and contaminants. It does react also with many other materials in our spaces. The removal is partial, so we do see some removal of chemicals, but only partially, and also that depending on which chemical we look, that removal is more or less complete. Particularly, I'm mentioning here polycyclic aromatic hydrocarbons or PAHs tend to react more than nicotine, which is a very important, as mentioned, chemical in third-hand smoke. So with carpets, we found a couple of very interesting factors. One is that carpets are a huge sink for these chemicals. We found levels of nicotine, for example, that were extremely high. And also that when we release the ozone has very little effect in reacting with these contaminants because the carpet itself reacts with ozone and it serves as a sort of a shield. So this is a kind of studies with real world materials that we're facing, and we're trying to learn more about, in particular this technology ozonation, which is not only used for tobacco contaminants. Many times these companies are hired to for restoration projects in homes that have been affected by wildfire smokes or other fire damage, and also by mold. So it's a broader problem than just tobacco smoke. Okay, apart from that work, we are closely collaborating with our colleagues at the lab from the bioscience area, which are shown in this photo here, Bohang, Antoine Snyders, and Jianhua Mao. In this case, we support, we're an analytical chemistry laboratory, so we support their studies, such as the in vitro studies on how the nitrosamines can damage the DNA in human cell cultures, and also in animal studies that show, for example, how mice that are exposed to third-hand smoke present more incidence of lung cancer. And this was a very productive collaboration over the years. And the other thing that is also very, productive is that our group, which is this one here, together with our biosciences colleagues, are part of a much larger consortium that is across the state of California. And you see with partners from UCSF, Riverside, San Diego State, and USC. And this consortium really covers a lot of various aspects of third-hand smoke and coordinates sometimes projects on such as field campaigns or biomarker discovery, biological studies, tobacco control policy, dissemination, or outreach. And just to give you an example, I invite you to visit this website here, thirdhandsmoke.org, which is, I think, a very effective way to reach a very broad, community across the world, really. And there have been even efforts to translate the materials to different languages. And it serves as a hub of information on anything associated with third-hand smoke exposures. Social media, the group that runs this is also very active in social media, and that really amplifies the message. And the other thing we do as a team in the consortium is summarize the state of the science and develop a roadmap for future directions, as, for example, we did a few years ago in this paper. I want to mention that one very rewarding aspect of the work we do on third-hand smoke is that more than a decade after we started, we see that the field really grew far beyond LBL, certainly, and far beyond California. And this is something that we could claim some authorship initially to the topic, or at least to have been among the very first groups that worked on this. And now it's been taken on by a number of researchers across the world and also organizations that really care about this. And I think we do have a real impact, and that's always very rewarding. So, okay, let's jump, and I have about 10 more minutes or so to go. Let me jump to the second topic, which is vaping. As mentioned, vaping was something that emerged only relatively few years ago and has been a revolution in how a number of smokers, switch. First of all, a number of smokers switch to vaping, which is in some aspects could be considered a good thing, but also it became very trendy and actually a very serious public health problem for young people that were never smokers that started taking up electronic cigarettes, which obviously is not a thing. So there has been great debates on vaping, and I'm not going to cover any of that. But what I want to say is our group's mission so far has been focusing on interesting chemical or environmental chemistry problems that are addressing the questions that have been popping up along the way, which this is a very dynamic problem. Every year we got new developments on vaping. So at the beginning, we had these first two studies in which the main question was this one. And right now, we have a good answer for this, but early on, we didn't even know what was on that vapor, right? Or vapor is in quotes because it's not really vapor, it's an aerosol. So we did address that to some extent. And let me start by saying brief description of what an electronic cigarette looks like. I'm sure many of you have seen it, or we have a battery in every case. We have this vaporizer, which is a contraption where we have a liquid, and the liquid gets heated in a coil, which is a resistance, where depending on the design, you could have a single coil or a dual coil. The resistance is somewhere around 2 to 3 ohms in general. And you can think of it, there is always the analogy of the light bulb, the old light bulb that we used to have with the higher the current through the light bulb, the more light it emitted. Here it's the same, the more current, the more the heat, the hotter the liquid gets and the more aerosol is produced. So an important aspect of electronic cigarettes is the design of the device, and the other important aspect is the formulation of the liquids. And here is where really thing got really interesting for us, because regular cigarettes are very homogeneous in their composition, in their emissions. It's very standardized. It's a standardized commodity, really. And the liquids are exactly the opposite. You could go to a store and find hundreds of little bottles with all kinds of compositions. So it's very difficult to study from that point of view. But let me give you a simplification of a picture. We have 3 main factors that the consumers look for. One is the flavor, and that's where all the variety comes. We tested, for example, here the classic tobacco flavor, a mojito flavor, and a bubblegum flavor, and you can find all kinds of flavors out there. The other factor is the level of nicotine, the concentration of nicotine. That's an important one. And the third one, and this is a little technical, is the so-called PG-VG ratio, where PG is propylene glycol and VG is vegetable glycerin or glycerin. And those are the 2 main constituents of a liquid. So the ratio between those 2 constituents result in properties of the aerosol, of the cloud that is formed, and also has to do with how smooth things are on the user. So one thing we found in this early work is that when we looked at the composition of liquid, it was fairly simple. And then we analyzed the composition of aerosol, and it wasn't so simple. We found about 30 or more compounds on the aerosols that are not in the liquid. And the reason is mostly that these compounds, in particular, the two solvents, propylene glycol and glycerin, when they get heated, they react, and you form a number of products from that thermal decomposition. So I'm not going to go through all those details, but we did a number of analyses to see what are those products, and then in the end, we determined the emission yields per puff, and with that information, we could predict the contribution of vaping to indoor air concentrations. So just to describe what we have here, delta C is a change in air concentration in micrograms per meter cube. This is the concentration, the increment in the concentration due to vaping. And we predicted that for a scenario where we have one person consuming at a certain rate in a home, and another scenario where we have multiple people consuming electronic cigarettes in a bar, or any place that looks like a bar that is large and you have many people in it. So the findings are interesting in the sense that for variety of conditions in which the products were consumed, we saw that rarely the levels exceeded what we call here the chronic and the acute reference exposure level. These are regulatory values that, again, tell you if the level becomes a health concern or not. So that means one person vaping in a home probably doesn't really represent a major impact. Now, if you have a number of people in a closed environment, then you could easily, in a couple of compounds such as formaldehyde and acrolein, you can easily cross that line. So that was our initial finding. Then I'm gonna show you quickly a more recent study in which we looked at another new technology. This is studies from 2021. You see, just a few years later, and technology evolved really quickly, and also the way people use these devices is very diverse. So for this particular technology, which is called sub-ohm, like the name clearly indicates, the major characteristic here is that the different resistance of in this case, we studied 5 different coil assemblies, it's always below 1 ohm, compared with more than 2 in the previous cases. And that means, if you remember that, the lower the resistance, the more current, and the more current, the more heat, and that means you release a lot more aerosols. And by doing that, the users can produce these wonderful clouds, like the one shown here in this photo. And so this particular type of vaping devices are used for they have certain use. It's not like everybody is choosing to use this. Now, what we thought was interesting was we assumed that such a large cloud would also produce thermal conditions that will produce a lot of these byproducts that are toxic. And the reality is, not so, they do, but not so much as we expected. And in this plot, I don't want to go into the details, but we found that formaldehyde, except if you go on certain particular unusual conditions, for the most part, you see the blue area means the emissions are actually lower than the older technologies. So the industry has made some progress in generating, aerosolization conditions that prevent the more toxic compounds to be forming, at least in large amounts. Another study that we did about the same time, this was published in 2019, has to do with let's say, a sibling of all these electronic cigarettes, which is what is called heated tobacco products. This is a kind of a hybrid because the technology is similar to electronic cigarettes, except that we don't use a liquid here. We use it's called stick, but in fact, it's like a small cigarette. So it's a small cigarette that is inserted there, and the user consumes it very much like you would do with a regular cigarette. We tested one particular technology that's called IQOS and was manufactured by PMI or Philip Morris International. And we did a number of various studies with it. Let me show you results for a couple of them. In the first place, we studied yields. Yields is how much is emitted per smoking event in this case. And we have a list of 26 compounds. We could determine the yield and compare our results with those from the manufacturer. The manufacturer was at that time presenting an amount of information both to the FDA, as part of the process of approval of this new product. And also it was submitting it, or it was published in the open literature. So this is information that the manufacturer actually was making public to show how, the benefits of a product. So one thing we were curious is, well, see if we could reproduce those yields. And in fact, I think our results show all these green boxes this is the ratio between our results and theirs, and it shows in general that it's very close. So the green boxes means that this ratio is close to 1. So that means that the emissions that we determine are not that far from theirs. And the other analysis that we did was comparing our yields here in the x-axis with the yields for the same chemicals from either combustion or common cigarettes and electronic cigarettes that we studied. And you see here the red data points are all above this diagonal line, which means anything that is above the line means that, in this case, the combustion cigarettes have higher yields than this IQOS device. And in fact, this difference is by 1 to 2 orders of magnitude. So it's very significant. For electronic cigarettes, it's a lot different, and you can say that there is a very vast dispersion, and it's hard to say whether electronic cigarettes or IQOS, which of the two is. I wouldn't say there is no clear winner there, but at least we can show that overall the products have their own profile of emissions, and they're all quite different. Okay, and the last one I have before I go is a very recent study we published a few months ago, 2023, and this was done in collaboration with our colleagues from the lab's advanced light source, the ALS. Here we are interested not so much on the evolution of the device or the technology, the hardware, but the evolution of the liquids. The liquids have also been, the formulations have been adjusted and improved to optimize certain effects. And in particular, one additive has been very common now, which is benzoic acid, or in general carboxylic acids, that are used to convert part of the nicotine in the liquid that is in a free base to acidify the system so that the nicotine becomes either monoprotonated or diprotonated. I apologize if I'm going too much into the technical details here, but it's important because this additive, by acidifying nicotine, what it does is it makes it more palatable to the user, and by doing that, by reducing what is called the harshness on the throat, it allows the manufacturer to increase the concentration of nicotine and make the product more addictive. So from that point of view, there is an important health impact that is associated with this process. So what we tried to understand in this study was how this factor, how the free base fraction changes as a function of the pH, but not on the liquid, but rather on the aerosol itself. And this was with a technique that was developed by our colleague Musa Ahmed and his colleagues at the ALS, that precisely allowed to use a very sophisticated method to using X-ray spectroscopy to look at how these different forms of nicotine are present not only in the core of the aerosol particle, but also on the surface. So I hope I mean, I apologize. I went through a lot of our work in a very short time, but I tried to really to cover as much as possible and to give you an overview or an impression of the various topics that we are working on. So I want to finish by mentioning here all of my great colleagues at the lab, you know, the current and number of people that have been at our group previously, and external collaborators and our collaborators at the California Consortium of Third Hand Smoke. So this is a group, a work that is done in collaboration with a great number of people, and it's been really very rewarding for me personally, and I think for our group. So thank you very much.
Thank you very much, Hugo. Very well done. Interesting work. And I wish all the teenagers out there would maybe get a hold of this research before they entered into a whole commitment with vaping. I know from just personal family experience, that's an issue out there. So let's see if there's any questions or comments from the group before we get on to our very last thing. And we're pretty close to wrapping up this evening. Any questions, comments for Hugo before we wrap up?
I have a question.
Go ahead.
And thank you, Hugo, for the great presentation. You mentioned ozonation as a form of remediation that you studied. Are there any other types of remediation that you have studied?
Certainly, there are. The most common remediation is using specific cleaning products to whether it's for a carpet or for the walls or for the more extended surface areas. And our colleagues at San Diego State University have been studying that. And if I remember well from their and they do have some paper published on this that I can share with you. They have followed for example, they went into a home, they did number of measurements before the cleaning event, and then they did this sort of intensive cleaning, and then did a couple of studies following up on that cleaning event. And it does have an effect initially, at least, but the problem is that a lot of the chemicals are at the level that is hard to reach by these cleaning products. So you can remove some on the more superficial level, but it's very difficult to really remove chemicals from the deep sources. And then over time, there is a slow diffusion process that brings the chemicals back to the top layer and then to the air. So the best solution is always to remove the materials and replace them. It's easier to do with a carpet, and it's not so easy to do with drywall or with the ducting systems, etc. So unfortunately, smoke is very pervasive, and one can find it in every material in the house.
All right, thank you. Any other questions or comments? Well, very good. Let's give Hugo a round of applause here. Thank you for the excellent presentation. Again, very informative, and we urge you to keep on with this really important research for public health and safety and all kinds of other good reasons. It's a great service. So we have just two more items to cover before we wrap up. One is to make sure there aren't any public comments, and this would be from people that may be attending that are not members of the community advisory group. Do we have any general public comments as we show on the agenda? That's where we are right now. Anything that people would like to bring up? Any questions or comments in that regard? And I'm not seeing any hands up there. So the last thing, the very last thing, and I will share my screen, has to do with potential future topics that we might cover as a community advisory group in the course of 2024. So I'm going to show you one of the slides that we put together in that regard. just to give you an idea, if this is of interest, this kind of shows what we've been talking about in the past, some of the ideas. This came out of our last session of 2023, as you can see, proposed discussion topics. And that includes opportunities for community collaboration, such as revisiting the presentation we had from Marin Community Energy at a future CAG meeting. Maybe one that's more attended, better attended, to fuel discussion of possible opportunities for collaboration, student placement, etc. And an update on community and nonprofit activities that might offer partnership opportunities for all of you on the CAG with the Berkeley Lab. Topic also was raised on local housing in conjunction with the city's updated housing innovation plan that's going to be coming out this month. I don't know, Sarah Moore, if you want to inform us about that. That could be an interesting topic, as it's a hot one that these days in the Bay Area and throughout California. Also hazard mitigation, resiliency. You heard Michael comment on this as one of our ongoing subjects to make the lab and the surrounding communities fire safe, to name one topic. And then biopreparedness, including indoor air quality, which we already just heard. There's other slides here, I think too much to go through. And Jen, if you agree, we can send this out to the CAG to review and comment. But these are just discussion topics that we've had from prior years. And it might spur interest or spark ideas from all of you. These last 3 slides just capture all the things we've talked about over the years with the community advisory group. So it's a lot of material there just to stimulate thought, but we said, gee, well, we know we have something to build off of with this proposed CAG topics list for 2024, collaboration, local housing, hazard mitigation, and biopreparedness. So we're thinking that could be a possibility for the coming meetings. The next one will be March 11th, by the way, so make sure your calendars are marked. Any comments on any of that? And like I say, we are basically out of time, but we can send this out to you for your closer inspection and review and comment. But if you have any ideas for possible topics that we can feature at our upcoming CAG meetings, we'd love to hear them right now. Anybody with any suggestions before we wrap up? Okay, Sarah.
Yeah, just a question on that, the housing innovation. My apologies, I'm not quite familiar with what that's referencing. That's not our housing element that was adopted just last year.
Good question. I'm not sure if I can answer that exactly what that topic was referring to, but are you talking, is this not the case? Is there not a City of Berkeley housing innovation plan? Is that not a correct?
I'm not familiar with that, but it may be that it could be something I'm not aware of, or it could be that the wording is slightly off.
Okay.
And I know it was at that last meeting at the lab, and I don't recall it coming up. So I'm just trying to get a little more context.
Okay. Gee, I would have to ask my colleagues here, Jen or Maria. I don't know if there was any additional detail on that particular subject.
I'm guessing we maybe wrote down notes incorrectly.
Okay, because I know the local hazard mitigation plan will be coming out.
I think that's what,
Okay,
that's what we were, yes.
Okay, that makes sense. And that, I know the intent was for that to be released here in January. I'm not sure if it's quite still on track for that. It may be February, but that will be released for public review very soon. So I wonder if there was just swapping. The housing element does have a lot of interesting things, but that was just adopted last year.
Yeah, I think hazard mitigation probably sounds more in line with what we've been talking about. Yeah.
Okay,
Yeah.
thanks.
Thanks, Sarah, for the clarification.
So what do you think about that, Sarah? Would that be a possible topic? Do you think it would be of interest to the community advisory group? And would you be available or interested in presenting the highlights of that.
Yeah, I probably wouldn't be the right one to present, but I'm certainly willing to reach out. I do think the local hazard mitigation plan would be of interest. It certainly is in line with a lot of things that the lab thinks about and the university and others here that make up the CAG, and it's of interest to the community generally. So I think it could potentially be a good topic.
I think it would be great because in the past years of the CAG, we have had CAG members do presentations as well, and that's gone over very well. It's been well received by the CAG, and we'd love to have the city's involvement there. If you can entice one of your colleagues from the city to come over and make that presentation, I think it would be very interesting and potentially fruitful to bring forward. So that's one idea. Are there any other ideas before we wrap up? And like I say, we can always receive emails from all of you. We're always interested in innovative topics, things we haven't covered, or even topics that we have in the past brought forward, because it might be time to reintroduce those topics. So we'll send out that list so you have it available, and we'll ask for your feedback via email as well, since we're short of time this evening. Any other quick comments before we wrap up? Okay, I'm interpreting the lack of comments as a desire to wrap up the meeting tonight. Thank you, everybody. March 11th is our next meeting, and we will see you there. Thanks for your participation. Great meeting and great.
Thank you, everyone.
Thanks, everyone.
Thanks, everybody.
Bye-bye.